is this garbage you're watching? I want to watch the news.
Are you making headway at least?
This is the news.
Now, let's see if we can block the radiation, protect you from it. Obviously, it's got some power. All right, so now let's see if we can protect ourselves. Remember, water does absorb microwave energy, even though this is the long wavelength and it penetrates deeply into a wet medium. If we take a couple of wet towels, a thickness of moist towels that I just soaked in the sink, and we put this in front, we're going to see if it affects the ability of this to drive the microwave, to drive the fluorescent tube. So we'll turn it on. Let's see what happens. Now remember, when I hold this in front, it fluoresces. And as I move this away from the source, you can see that it works out to about, oh, heck, almost 2 meters here. It's pretty far. But if I place the water barrier in front, like this, no fluorescence. If I start this up first and then block it, you'll see that the energy cuts out about halfway as far away. Again, all the way out to about here, all the way out to about here, probably 2 meters almost. But if I place this water barrier here and then try to drop the tube, it goes out in about 1 meter. So this doesn't absorb all of the energy, but the water does absorb even the low frequencies significantly. And if we had the higher frequencies, this would be a complete protection. What's nice about that is that if you were potentially facing a microwave attack, if you just had a couple of water bottles and a towel, you could hold it in front of your face and you'd probably protect yourself from a weaponized microwave system. And if you're thinking, well, that'll protect my face, but not the rest of me, just get a beach towel, flood it with water, hold it up in front, and you could dance away, and you're perfectly safe. Easy, compact, and certainly not a threatening defense system. The other way that we can potentially protect ourselves is taking advantage of the microwave interaction with metal. Any kind of a conductor will act as an antenna and will actually reflect the energy from the microwave back toward its source. So let me show you how that works. All right, next test. This is some thin sheet metal, and the microwaves will reflect off of the metal. And again, we should be able to block the energy simply by placing the metal between the source of the microwaves and the fluorescent tube. Turn the buddy on. Now you can see the light fluorescing. Watch what happens when I drop the metal in the way. Turns it right off, turns it on. Very effective. I'm now going to show you how it can reflect the energy to a new location. It doesn't just absorb it, it reflects it. All right, so what I'm going to do is demonstrate the lateral aspect of the distribution of the microwaves. And so you can see that in order for this to glow, it pretty much has to be almost at the edge of the antenna. But once you get not even to the edge of the table, it dies off. I'm now going to put a metal reflecting plate in front, like that, to redirect the light this way. And we can see, when I put this in front, how much farther laterally the radiation goes. This is working as a deflector, not just blocking the radiation and protecting my parts, but sending the radiation laterally. Okay, next. Now, sometimes you're not going to have access to a great big metal plate to protect yourself. So a trick would be to take a poster with some sort of a theme or something interesting on it, like this, and laminate between the two surfaces some aluminum foil. So you've got metal in between the two layers of plastic. And this will also block the radiation. So if I set this in here like this, you can see that it glows. And when I place this in front, it kills it. Can you see that? Yep. Now, another property of microwaves and their blockage by metal or any kind of a conductor is that microwaves or any kind of electromagnetic radiation cannot pass through a space smaller than its wavelength. In this case, about 12.5 centimeters. That's why this is the old hacked door from the microwave that I got this from. That's why they put these metal screens in the door. The door itself is made out of plastic and wouldn't block the microwaves from getting out. But these perforated screens allow you to see through them, but at the same time, they block the radiation. So what we're going to do now is try a perforated metal screen like this. I've applied this screen to our riot shield. And this has a couple of advantages. First of all, you can see through it. You retain the protection of the riot screen, but also protect yourself from the microwave. So let me show you how this works. Now this is where I get a little daring, okay? This is the fluorescent tube, and it clearly glows. But if I take this screen and I put it in front of the beam like this, I'm standing in the microwave beam, and it's protecting me. But not here. Here, but not here. And I feel fine. In addition, the metal will actually support a voltage. That's how some of the energy is handled by from the microwave. Some of it is reflected, some of it is absorbed. The point is that because this perforated surface allows me to see through it, and because it's convex relative to the beam, the energy that's being deflected off of this to the sides, see if we can get this to go, is spread out. And so as a result, you don't burn your friends who may be standing around you because you've made the energy far more diffuse by the time that it would get to the backsides of anybody around you, which is kind of a nice touch. We're not trying to weaponize anything here. But again, I feel fine. Just make sure that when you do use the screen, it's aluminum screen, not the fiberglass that most modern window screens are made out of. It needs to be in aluminum. And finally, there is a small voltage that can develop in the conductors here, but it's small enough and it is lost in the resistance of the aluminum so that you can touch this and you don't get a shock. Pretty neat, huh? So those are some interesting tests. We've demonstrated that you can effectively block microwaves by absorbing them, as we did with the wet towel, or you can reflect them with a solid piece of conductive material like a plate, or like a stealthy piece of aluminum foil placed on the back side of a poster, which you might be carrying if you're going to some sort of a protest. In addition, you can also block it with a perforated conductor, like aluminum window screen. And this also has the advantage that you can see through it, and because of the convex surface, will diffuse the energy so that you pose less of a risk to the people around you. Kind of a nice thing to keep in mind. In any case, I want to hope that you stay safe. And we really appreciate your spending your time and watching. If you have any comments or have any questions, put them down in the comments section below, because I read them all and I try to answer as many questions as possible. And you also give me some good ideas for future videos. The best thing you can do for our channel, if you like the kind of material that we cover here, is to subscribe. because by subscribing, we grow. And as we grow, YouTube will distribute our videos to a wider audience, and it helps us to support us for all of the time and the money that we spend to make these videos. In any case, stay safe, have a wonderful evening, and we'll see you soon.